This is code.org. Check for understanding, complete the blanks. In order for a binary search to work, the list needs to be blank. Students, use your resources. Hopefully you know this off the top of your head. But if you don't, code.org provides us a ton of resources. And let's use them. I'm going to go ahead and go back to the main portion of this lesson. And let's see. Here I am on binary search, notice. So you discover a better searching algorithm that can perform more efficiently if the list is already what? Sorted. So I am going to put this whole thing in here. Is already sorted, right? And I'm just using resources. In the blank case scenario, all right, well, let's see. Do I see the word case here? I don't. Let's look at searching. And let's see, case. Oh, interesting. All right, you can learn how to use execution counts to determine the best, average, and worst case. If I want to learn more about that, we can look at some definitions. The worst case is the most number of executions an algorithm can perform. So a linear search, like we discussed earlier, keep in mind, is if you are searching linearly, that means you're just walking through a list of numbers, right? If I'm searching this linearly, let's say I'm searching for 95, well, I'm going to have to take 9 steps. 1, 2, oh, not this one, till I get there, right? Now, if I'm searching linearly and I'm looking for the number 2, well, instantly I find it. However, for a binary search, right, we're chopping it in half. We look at the first number, the last number, and the middle number. If the middle number is greater than our current number, then we look at this half. If it's less than our current number, then we move over and look at this half, right? So a binary search theoretically cuts the time in half. However, a binary search would not be faster than a linear search if a linear search is for the first number or the second number, binary search won't be faster. So when it is faster, though, is the worst scenario of linear. When you have to go through a bunch of stuff because it's way down here. So the worst case, binary is always going to be faster. And that's why we have worst defined here. And then what is this? Linear or sequential search, which is what we were going over next. Boom. Students, please, please, please use your resources. Code.org gives them to us for a reason. Onward.